There is a rising interest in running stateful workloads on Kubernetes. You may not be ready to run your database there, but if your organization is exploring Kubernetes for the rest of their infrastructure, now is a good time to get started getting familiar. I'm Derek Downey from Distributed DBA. Today, I'll show you how to get started running MySQL on Kubernetes. To get MySQL on Kubernetes, you're going to need a couple of things. First, you need to have Kubernetes running somewhere. You can leverage your organization's Kubernetes deployment or provision one on a cloud service. Or if you're just getting started, you can get a basic Kubernetes deployment right on your laptop. There are many options for running Kubernetes locally, but in this video, I'm going to use Minikube. Second, you will need an operator. In Kubernetes, an operator packages an application to better utilize the Kubernetes API to configure and run that application. For example, you can expect a database operator to be able to change the configuration of the database. But you should also expect the ability to take backups and rotate passwords. So with a MySQL operator, you can do those things using native Kubernetes commands. Let's get started with Minikube. Minikube is a project by the Kubernetes team to get a simple Kubernetes deployment installed locally on limited resources. For it to work, all you need is a laptop with 8 to 16 gigs of RAM. Really, you need about 4 gigs to devote to Minikube. So if you have 100 Chrome tabs open, you might want to close some of those to make room. Minikube works by deploying some sort of virtualized environment. This can be a VM using VirtualBox, or it can be Docker. I'm going to deploy Minikube with my Docker environment under Windows WSL. Since my WSL environment is Ubuntu, these steps should be familiar if you are running on Linux as well. So the very first thing that we need to do is grab the binary. And once we have the binary, then we need to install it to be accessible. Now that we have the Minikube binary, then we need to go ahead and start up our Minikube cluster. Now what Minikube is doing as it starts up is ensuring that it has the latest version of Kubernetes as well. So now we have access to the kubectl command. So now we can see all of the pods currently running on our Minikube cluster. So that's it. Now we have Minikube running. Let's take a look at the operator. There are many choices for the MySQL operator. Oracle maintains the MySQL operator, and MariaDB does as well if you are using MariaDB. For this post, I'm going to use Percona's MySQL operator. The end result of using this operator will be several pods. A pod is basically a running application that is scheduled by Kubernetes. And the pods will actually deploy Percona XtraDB cluster, which is based on Galera. But a Galera cluster is a pretty good option for Kubernetes as it allows self-healing if one of the pods stops working. You will need to grab the file from Percona's GitHub repository and make any modifications to the YAML configuration file to fit your deployment. Once we have the file, we can go ahead and extract it. This will take a while. It's kind of a big file. And there we have it. So now we'll go ahead and get into the directory. Now what we want to do here is reconfigure the basic setup for this environment to be aware of the limited resources that we have on our laptop. So to do that, we're going to limit the number of memory and CPUs. We're actually going to comment it out. This is just a YAML file that describes how this operator will deploy the Percona XtraDB cluster pods. So we're going to actually comment these out because we don't need them. And that will allow Minikube to use the full resources. Now, we're also going to change this topology key to none because we don't need it in this configuration. And of course, because this is an unexpected production environment, we're going to allow unsafe configurations. That just says that this is not recommended for production. So don't run this setup in production. Now, the two things that we need to do are to tell Kubernetes to apply this operator. This is how it gets discovered. And then we'll want to deploy the YAML file configuration for MySQL that we just edited. So this is the step that will actually allow Kubernetes to deploy the Percona MySQL pods. So there, our cluster is created. You can check the status of the cluster by doing the kubectl get pods command. And we can see that one of these are running, but the entire pod is still initializing. Okay, so you see that we have our cluster running, and we're going to try to connect to it. So a couple of things. The Percona operator will generate several secrets for your cluster. So the first thing we need to do is grab those secrets. So you'll see here a bunch of different secrets for the users on the database. We're going to grab this root user. And what we're going to need to do is then decode this, because the output of this command is in base 64. And we'll grab that secret from this output. Now, we're assuming that you don't have Percona or MySQL client running. So the first thing that we're going to want to do is start a new client pod on Minikube. There we go. We went ahead and started it. And now what we can do is we can connect into our PXE node. You may not be close to running your MySQL on Kubernetes in production, but if you are a forward-thinking data guardian, you might want to start testing it out. Using Minikube and the Percona MySQL Operator, you can quickly get a running version of MySQL on Kubernetes on your laptop. Good luck! I'd love to know how your Kubernetes journey is going for you.